Good day everyone, welcome to another episode of My Crypto Online Tutorial. Today, I'll be talking about the topic binary operation. First of all, what is the meaning of binary operation? Binary operation is an operation in mathematics that deals with combination of sets. In binary operation, I'll be making use of the following symbol. I have asterisk, I have this circle here, I have this, and I also have this. We're going to make use of all these symbols. We have properties of binary operation. Number one, we have commutative property. Number two, we have associative property. 3, we have distributive property. Number 4, we have identity element. Number 5, we have inverse element. So we are starting with commutative property. You see, an operation is said to be commutative if A asterisk B is equals to B asterisk A. What is the meaning? In commutative, we have two signs that obeys commutative property, which are plus and multiplication in commutative property. What do you mean of commutative? When we have 3 plus 2 is the same thing as 2 plus 3. 3 times 2 is the same thing as 2 times 3. That is the meaning of commutative property. A asterisk B must be equals to B asterisk A. Number 2, we have associative property. Associative. In associative, A asterisk open bracket B asterisk C must be equals to A asterisk B asterisk C. In this also, sign that enter it is plus and multiplication. A asterisk open bracket B asterisk C must be equals to A asterisk B asterisk C. Number 3, I'm going to explain everything in a detailed example. We have these distributive property. In distributive property, we have A asterisk open bracket B asterisk C is equal to A asterisk B asterisk A asterisk C. For distributive property, we have A asterisk B asterisk C is equal to what? A asterisk B asterisk A asterisk C. Number 4, we have inverse. We have identity element. Identity element A asterisk identity element must be equals to A. Whatever we put in front of identity element, we must get it back. But if we have B asterisk identity element, it must give us B. If we have C asterisk identity element, it must give us C. Now, we have what we call number 5, inverse element. In inverse element, we have A asterisk A inverse must be equals to identity. Whenever you have an operation, A inverse must be equals to identity. Now let me now go to tabular form of binary operation. Tabular form of binary operation. Like we have this example. If I have something like this, P, Q, R, P, Q, R. Under P, let me do it. Q, P, P, Q, R. R, Q, R, P. The question has been find the identity element. To find the identity element, we are going to use, we'll bring out and write solution. I'm having P, Q, and R. I'm also having P, Q, and R. So I'm having Q, P, R, P, Q, R, Q, R, P. We are asked to find the identity element. To find the identity element, we are going to have that from this place, our identity is A asterisk identity must give me A. Whatever you place under as identity must give you that same back. If you have P asterisk identity, it must give you P. Q asterisk identity must give you Q. Now, let's go. P asterisk P does not give us, it gives us Q. P is not an identity element. Q asterisk P is P. That's not an identity element. But R asterisk P is Q. That's not an identity element. P asterisk Q gives us P. I can note that. Because when I place P in front of Q, I got my P back. Q asterisk Q give me Q. That's an identity element. R Q give me R. I can then say from there, I can say P from the third column, comma, P asterisk Q equals to P. Q asterisk Q equals to Q. R asterisk Q equals to R. Therefore, my Q is the identity element. My Q is the identity element. Thanks for watching.